Chapter 2 is about organizing data, so we're going to learn several different ways to organize different types of data. The first section, section 2.1, is about organizing qualitative data. So if you think back, what is qualitative data? It is our categorical data, non-numeric, sorting into different categories. So our categorical data is what we're going to discuss, how to organize that first. And we like to use what's called a frequency distribution to help us organize our information. So we list each category of the data and then the number of occurrences for each of the different categories. It's kind of like a tally of how many occurred in each category. So let's look at an example. So the problem is that a physical therapist wants to determine the types of rehabilitation required by her patients. To do so, she obtains a simple random sample of 30 of her patients and records the body part requiring the rehabilitation. So Table 1, which is from your textbook, has a list of all her 30 patients and which location their rehab had to occur. So we're going to create what's called a frequency distribution by listing the body parts. We're going to go in alphabetical order. Technically, you can use whichever order you want. The book does not go in alphabetical order. I just think for consistency, going in alphabetical order makes sense, but it really doesn't matter what order you go in. And we'll tally up how many of each and put the number in a frequency column. So the next page, we have a frequency distribution, which is a chart. I have listed all the different body parts in alphabetical order. I'm using a letter to represent each body part. We'll use that later. And now we're just looking for the frequency. So how many back rehabilitations, how many elbow, how many groin, hand, hip, knee, neck, shoulder, and wrist, how many of each kind. So go ahead and count up. Back, how many back? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 back injuries. And then we'll tally up. Elbow is next. So 1 elbow injury. So just 1. Groin. There's 1, and that's all. Groin only has 1. Hand. There's 1, 2, and that's it. 2 for hand. Then we have hip. 1, 2, and that's it. 2 for hip. Knee. 1, 2, 3, 4, 5. 5 for knee. Neck. 1. That's it, just 1 for neck. Shoulder, 1, 2, 3, 4 shoulder injuries. So 4, and then wrist, 1, 2 wrist. And if we did this right, if we add up all of our frequencies, we should have a total of 30. Because it represents all 30 from the sample. So those are our frequencies for each of the categories. They should total 30. Now we have another column for relative frequency. That might be something new for us. So on the next page I've described what a relative frequency is. So it's calculated by taking the frequency, which is the one we just got, from each category, and we're going to divide. So we're taking the frequency from each category and divide by the total number of entries, which in this case was 30. That is your sample size, which remember is the lowercase letter n. So we're going to divide each frequency by the total. Frequency by total, divide, divide, divide. Now in this course, we use 4 decimal places for precision. That is very important. So after the decimal point, 1, 2, 3, 4, digits, and that helps us be very precise. We're going to be graphing this in a minute. So for graphing, we're going to use 2 decimal places, so we'll round off to just 2. But if you're not sure how many to use, always use 4. That is our magic number. Sometimes the book will round off to 3, but it doesn't hurt to have 4, and then you can easily round it if you need to. But 4 is the statistical standard across the board, 4 decimal places. So let's take each frequency and divide by the total. So 12 divided by 30 is just 0.4. So we can just put 0.4, or we can put 0, 0, 0 to be super precise. And 1 divided by 30 is 0.033, and the last one will round to 3. Again, this will be 0.0333. Hand is 2 out of 30. 0.066, and it keeps on going, and we need to round, so the last one would be 7, and then again 0.0667, 5 out of 30, again we'll need to round, 0.1667, and then 1 out of 30 again, 0.0333, 4 out of 30 is 0.1333, and 2 out of 30 is 0.0667. Now we rounded that last digit, but having 4 decimal places, we're pretty precise. If we add all of these relative frequencies, we should get to 1.0000 exactly. We rounded, so it'll be off by a little bit. But if we didn't round, if we used all the exact numbers, it would round to exactly 1.0. That represents 100% of your data. We'll be using that concept throughout the course. All of your data, all the frequencies have to add to 1, which are all your relative frequencies have to add to 1, which should make sense. This is 30 out of 30, which again is 1.0. So we're looking for that magic number 1 if we add all those together. So this whole table together is called a frequency distribution. It has your categories, your frequencies, and your relative frequencies. We'll see this often throughout the course. So the first type of display we're going to create is called a bar graph. Maybe heard of this before. It's kind of a simplistic graph. So we're going to label each category of data. On either the horizontal or the vertical, we're going to go with horizontal. Sometimes you'll see them labeled on the vertical, but we're going to stick with horizontal. And then the frequency or relative frequency, either one is fine, on the other axis, whichever one you didn't use. We're going to make rectangles of equal width. That's very important. Equal width are drawn for each category. And there must be a space between each rectangle to separate the categories. The categories can go in any order. It really doesn't matter. We're going to go alphabetical again just to be consistent. So we're going to create 2 bar graphs, one with frequency and the other one with relative frequency. So let's find our frequency distribution. And the next page I have 2 empty grids for you. Now the scaling is up to you. Generally, we find the highest value, the highest frequency is 12. So we know that our vertical axis needs to go up to at least 12. And I believe I've marked it to where you can just count all the way up to 12, 9, 10, 11, 12. So usually it's scaled for you. I just kind of left it blank just to talk about how we draw the frequency side. And so we're going to label this frequency. Always label your axes frequency. This is going to be the types of rehab. I'm going to use the letter abbreviations so that it's more clear. I'm going to write them between the tally marks, starting with B for back. Then I'm going to skip a space, and then E for elbow, skip a space. G for groin, skip a space. HN for hand, and then HP for hip, and I'm skipping a space every time. Let me try. Maybe. It's gonna let me zoom in. So keep skipping spaces. Knee, skip a space. Neck, skip a space. Shoulder, skip a space. Wrist. There should be room to list each category and a space in between. And then for the first one back, we're going to go all the way up to 12. You might want a ruler if you want your lines to be nice and straight. Nice, very tall bar for back, all the way up to 12. Then for elbow, we just have 1. Groin, we just have 1. Hand, we have 2. Hip, 2. Knee is 5, so I'm going to go all the way up to 5. And then neck is 1. Shoulder is 4. 1, 2, 3, 4. And wrist is 2. So this is a bar graph. Generally we shade the bars. It's not that big of a deal, as long as you can see where the bars are and where the spaces are. And again, the categories can go in any order. Your textbook has them in a different order. I just put them in alphabetical order. So that is a frequency bar graph. Now we're going to make, using the same set of data, another bar graph using the relative frequency. So we're going to use our decimals this time. So looking at our decimals, our biggest is 0.4, biggest is 0.4, and then smallest will go down to 0. So on your scale, I believe we can count by, this can be 0, 0.05, 0.10, 0.15, 0.20, 0.25, all the way up, counting by 500ths at a time, 0.40, and we can stop there because we know our highest is 0.40. So you scale that however seems appropriate for you. And then we'll do the same thing, list our categories. Back, elbow, groin, hand, hip, knee, neck, shoulder, and wrist. And this time we're going to have to kind of round off, and we're going to have to kind of eyeball this. So relative frequencies, if you're doing a bar graph by hand, it's hard to get exact, but we're going to just graph it the best we can, and we're going to have to round these off. So if you want to round these off, this would be 0.40. I'm going to use the squiggly equals for approximately. This is about 0.03, 0.03. This would round off to 0.07. This would round off to 0.07. This would round off to 0.17, 0.03, 0.13, and 0.07, if that helps you. Now, again, we'll just kind of have to eyeball in between as best we can. So back is up to 0.40. We have 0.03, so pretty short for elbow. Groin, also pretty short. Hand is 0.07, so just under 0.10, and you just do the best you can. Hip, same. Knee is up to 5, which was 0.17, right under 0.20. Whoops. Ignore that. And then neck, 0.03, shoulder, 0.13, and then wrist, 0.07. So you just do the best you can going up to between the two. That will give you the best picture. So I'd like you to look at both of these. They both give us the same information. They both quickly tell us the most or the highest frequency, which would be also the relative frequency. It tells you which ones are the same, where we kind of have a little bit of more different types of rehab. So they give you the same information, so it doesn't matter if you use frequency or relative frequency. The bar graphs will look relatively the same. It's just the scales will be different. So the homework will tell you which one it wants you to look at, frequency or relative frequency. I would say in general we use relative frequency because these are like percentages, and therefore we can compare different size samples using percentages. So I would say relative frequency is usually used more often. Frequency is only based on the specific sample size. Relative frequency can be used to compare different sizes. That's how to make a bar graph. And the rest of this section, I just kind of want to look over the different other types of displays. The only one we really want to focus on is how to make a bar graph. They also have side-by-side bar graphs on page 67 of your textbook. If you want to compare two data sets, one from 1990 and one from 2009, you would put the bars side by side. You'd be consistent on which one goes on the left and which one goes on the right. There's generally two different colors that are very distinct, so you can see them very clearly. And they have to use relative frequency for these because we have to compare with the percentages, because if you see the totals are different sizes. So we cannot use frequency when we're comparing. We have to use relative frequency. Those percentages are going to help us compare. We also have the classic pie charts. You've probably seen these all over the place. Microsoft Excel does a nice job making pie charts. Trying to do a pie chart by hand is just insane because the size of each slice or sector is proportional to the relative frequency of that category, and it's all based on degree measure out of 360. So finding these degree measures can be tricky, and then trying to draw it by hand at a particular degree measure, it's just almost impossible to make a nice pie chart by hand. So we don't really have to worry about how to make a pie chart, and I think we all are familiar, hopefully, with how to read a pie chart. Each slice represents a different category with different relative frequencies, and the bigger the slice, the higher the relative frequency. So hopefully this is clear. Generally each slice has a different color. There might be a couple questions where you have to just read a pie chart, but that's not really a big focus for this course. So the big one for categorical data, for qualitative data, is making a bar chart. The next section deals with organizing quantitative data. This is where we're going to be putting most of our energy for Chapter 2. It's quantitative data. Remember, quantitative data is our numerical data. And the two different types we have are discrete. I missed a letter there. Discrete and continuous. And so we'll talk about different ways to display discrete and continuous data. So we'll be making the same data tables, those frequency distributions, and then we're going to make something called a histogram. We'll learn how to make it for discrete and then continuous. There's also something called a stem and leaf plot that we'll get familiar with. Dot plots and time series graphs are not things we really focus on. I'll show you what they look like, but we spend most of our energy on histograms and stem and leaf plots. All right, so for discrete countable data, when there's no in-betweens, we have a scenario that a manager of a Wendy's fast food restaurant wants to know the typical number of customers who arrived during the lunch hour. So they took 40 randomly selected intervals of time and counted how many people came into Wendy's during that chunk of time. So we have 7, 5, 2, 6. This is the number of customers that arrived at Wendy's within those 15-minute intervals. And the textbook has already organized this for you. They tallied up how many of each number and the frequencies, and then they even went so far as to give us the relative frequencies. So this is the frequency distribution that's already been done for us. So they've already tallied them up and gotten us our relative frequencies. And using that, we're going to create a histogram for our data. So histograms look like bar charts. except there are no spaces between the bars, and they have to go in numerical order from least to greatest. And these are the actual values go from least to greatest, not the frequencies. For discrete data, the bars are centered over the values, and I'll show you what that looks like. So we're going to construct a histogram for the Wendy's data using our relative frequencies. So I have the charts on here as well. So we have our raw data. This is what we call our raw data. It's been organized in our distribution chart. Distribution. And now we're going to take those numbers and make our histogram. And again, we're going to use relative frequencies to do this. So I'm going to label it right now, relative frequencies. And this is going to be the number of customers. And we're going to go in order from 1 to 11, and we're going to put the numbers between the tally marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm going to go up to 11. And we're going to figure out, looking at the relative frequencies, we're going to find the highest, which looks like 0.275. And that way it'll help us know how far to go on the side. If we go up to 0.30, we can count by 500ths. Sorry, yeah, 500ths again. 0.10, I hope I line this up right. I think I'm off by 1. Should be 0.05, 0.10, 0.15, 0.20, 0.25. This will be 0.30. Sorry about that. So start from the bottom. I started from the top. Don't do that. Always start from the bottom so that you can see your relative frequencies. Let me write that again so it looks better. So we have 0.05, 0.10, 0.15, 0.20, 0.25, and finally 0.30, and we're not going to use that top tally. Alright, and we're going to have to round off our relative frequencies. So 0.025 is about 0.03, and then this is also about 0.03. This is about 0.18. This is about 0.28. This is about 0.13. This is about 0.03. So if it helps to round off to 2 decimal places, and that'll help us make our frequency, our histogram. So let's see, let's go up to 0.03, which is right below 0.05. The next bar is going to start immediately. It's not going to have a space. So then we'll have 0.15 immediately touching the previous bar. Then we'll have 0.03 again, and then 0.1, and then 0.18, and then 0.28, which is way up there. 7 gives us 0.13, 8, 0.05, 9 is also 0.05, 10 is 0, it's a big old blank spot. There was not a 10 in our raw data, but when we make our list, we can't skip 10. If we skip 10, it will throw off our histogram. So we just put a flat line at 10. And then for 11, we're at 0.03. So our histogram, they're all smushed together one after the other. And this, in chapter 4, will kind of smooth, or chapter 3, will kind of smooth over these histograms to kind of look at different shapes that they make. And so this is Wendy's, the Wendy's data. So you always want to title your histogram, you always want to label your axes, and do a nice job scaling, and make it very clear what we're looking at. So that's a discrete histogram, the numbers and the bars are centered. So the bars are centered over the numbers. For continuous data, it's different. So for continuous data, they can take on infinite values, so the data must be organized into equal size intervals. I call them intervals, this textbook calls it classes. Each class has a lower and an upper limit, and class width is the size of each class and it's supposed to be equal. So if you look in this table, we have a range of ages, and they're all of equal sizes. In this table, we have a range of ages. They're almost of equal sizes, except for this last one kind of goes off track and does not have an equal size. So we want to have all of our classes or intervals be of equal size to help us count the different frequencies. So for a continuous histogram, is slightly different for discrete. The bars are between the class limits, not centered over the values. So it's going to be between here, which looks a little bit different. So this is a different set of data. It's a 5-year rate of return of mutual funds. So these are all percentages of how much you're getting back on your return. And you notice there's all kinds of different decimals. They're all over the place. We can't count how many 3.27s because that's the only one. We can't count how many 3.53s because that's the only one. So each one's unique. And they all take on an infinite amount of values. So what the book has done is organized at any rate between 3 and 3.99 goes in that interval. Then 4 to 4.99, 5 to 5.99, and it continues. Notice they put 7 to 7.99, even though 7's not in our chart. So there's 0, but that's important to keep everything in numerical order. And then again, there was no 9 to 9.99, but we still have the interval for it. So once we start, we have to keep equal and keep consistent and not skip any until we get to the maximum value. So usually this is done for you. If you have to do it yourself, you just have to use your best judgment and decide how you're going to separate the classes. You don't want too few classes, you don't want too many classes. But for this course, these will be done for you, ready to go. And then you can do your frequencies, how many of each, and your relative frequencies. Alright, so now we're going to make a continuous histogram using these values. So this will be a continuous histogram. This time, we're going to put our numbers on the tally marks. You can either start at 0 or start at 3. I think I like to start at 0, 1, 2, 3, 4. I'm putting the numbers not between the tally marks, but underneath the tally marks. 5, 6, 7, 8, 9, 10, 11, 12, 13. And we can keep going if you want to. I always like to start at 0 unless the data is way off, and I'll show you how to take care of that later. But generally we start at 0, even though our first class is not till 3. And then we're going to use frequency this time to make our histogram. So frequency. The highest frequency looks like 16. And I have 1, 2, 3, 4, 5, 6, 7, 8 marks. So I'm going to count by 2s. So we have 2, 4, 6, 8, 10, 12, 14, 16. You can keep going to 18. This time the bars